Very good afternoon, respected ladies and gentlemen. I would like to thank EMAK Network for having given us this opportunity to present our findings. And also like to acknowledge the findings in this particular presentation in the context of a project that we are working on for the past 2.5 years. This project was funded by the World Bank JEF and implemented by SIDBI in 5 clusters in India, all of them in MSME clusters. We are working majorly in the Faridabad mixed cluster, where we have 10 set of industrial sectors. So with due acknowledgement to the SIDBI for the great learnings we have had under this particular project, we have been working in 400 MSME units in Faridabad, starting from walkthrough audit to detailed energy audit, and later on towards implementation support. As I said, since this project is 2.5 years long, there is scope for providing all these services in the time frame. We have conducted detailed energy audit in 260 MSME units, and as I said, across 10 industrial sectors, starting from forging, foundry, chemical, textile, machining, etc. Coming to today's context of today's presentation, waste heat recovery. Among these 10 sectors, we have recommended waste heat recovery systems in forging, foundry, chemical, textile, and die casting units. But I'll restrict my presentation towards only the forging sector, because that is the sector wherein we have majorly recommended in terms of numbers, in terms of presence in Faridabad. If you look at the forging furnace and the fuel mix in Faridabad, 58% or the majority of the furnace users use PNG or piped natural gas as fuel in their furnace, followed by furnace oil at 30%. And here we are talking about reheating furnaces, where it's a box kind of structure, where furnace oil or PNG is pumped into the furnace with fresh air at ambient temperature, generally going to the furnace, and the furnace is to be maintained at 1100 degrees centigrade on a continuous basis. The flue gas temperature that is leaving out of the furnace is generally in the range of 600 to 900 degrees centigrade. I'll come to the numbers later. And therefore, there is an opportunity to capture the waste heat from the flue gas of the furnace to preheat the air that is going into the furnace, and thereby save fuel. If you look at the typical efficiencies of a forging furnace, we have had opportunities to work in more than 30 odd forging furnaces in Faridabad. And again, talking about the PNG furnaces, we have found that on an average, the efficiency of the furnaces range at around 33%. And on the right side of the Sankey diagram, you would find that the major loss is happening on account of dry flue gas loss, followed by the other reasons. The major energy efficiency recommendations that one can make in such kind of situations is obviously waste heat recovery, excess air control, insulation, and insulation improvement, opening loss reduction. The flue gas loss, dry flue gas loss, which is at 46%, is contributed by or can be reduced by two recommendations which are listed here: the waste heat recovery and the excess air control. If we consider 20% of this dry flue gas loss recovery to be reduced with the help of installing a waste heat recovery system or a recuperator, we are talking of increasing the efficiency of the PNG-fired furnace to go to as high as 53%. This is comparable to the efficiencies of induction billet heaters or induction furnaces, and therefore it is a very opportune for forging units to go for waste heat recoveries. However, I'll talk about the barriers and the technology-related issues later in the presentation. Talking about the other recommendations, as I was mentioning, the other recommendation by which we can reduce the dry flue gas loss is the excess air control system, wherein we talk about monitoring the oxygen at the exit of the flue gas and controlling the air, quantity of air that is pumped into the furnace so that there is no excess air. In other words, if we reduce the quantity of air that is going in at ambient, which is over and above the actual requirement, we are for no reason increasing that particular quantity of air from 30 degrees centigrade to 1100 degrees centigrade, and again leaving it at 900 degrees centigrade to the atmosphere from the flue gas. So the fuel that is going in heating that incremental air volume to raise it to that particular delta temperature can be saved with the help of a flue gas analyzer. It can be a portable flue gas analyzer or an online flue gas analyzer where it continuously samples the flue gas from the point of view of oxygen percentage present. And for every particular fuel, there is a stoichiometric requirement of air that is to be pumped into the furnace. And there is a margin that is made available for excess air. If one exceeds that excess air limit, there is an opportunity to reduce that with the help of reducing the air that is going to the furnace. However, having recommended this excess air control in Faridabad, in many of these forging sector units, we found that the receptiveness is not very high. The reason behind this is that the SME units actually don't understand reducing the air going in, reduction of air going in. They understand more in terms of temperature, reduction of temperature. After a lot of iterations, we found that the receptiveness to control of air or PNG or fuel for that matter, with the help of sensing the temperature of the furnace, has more receptiveness rather than oxygen. And this is out of our learning, out of our 2.5 years of implementation support under this particular project. The other recommendation is on the insulation, increasing the insulation, reducing the skin loss that is happening from the surface of the furnace, and the opening loss. As you can see in the picture on the left side, you would find that there is an opening which you would see, and a lot of radiation loss obviously happening at that particular place. This is still a better example. Typically in any furnace, obviously there would be material feeding door and a material exit door. So in almost all the units, we have found that the doors are wide open, and therefore there has been recommendations of reducing the opening and also improving the insulation. On the right side, you would see a picture where after our recommendation, they had installed a insulation door. The receptiveness to this particular suggestion is high because of the fact that for MSME units, for forging units, furnace itself is an O&M item. They get it fabricated by a local fabricator at their own factory premises, rather than procuring a very professionally designed from some reputed vendor. And therefore, fabricating a door for them is not a big deal. Coming back to the subject of waste heat recovery, you would find on the left side again, there is a box-type cylindrical structure which they call as a waste heat recovery system. And this is primarily to preheat the furnace oil that is going into the furnace. This is more out of desperation of preheating the furnace oil to save jamming of fuel during winter and to make it more viscous during winter season. So this is a case not to save energy, but to an operational measure. On the right side again, on the top, you would see that there is a local fabricated recuperator that I would find, and the temperature gains on account of this recuperator we had measured are marginal. So when we studied so many MSME units, we plotted all the operating parameters across this particular, in this graph, as you would see. On the top, you would see the various kinds of fuels, and I would draw your attention to the light blue line, sky blue, which is the flue gas temperature, which is exiting the flue gas of the chimney. You would find that the temperature ranges from 600 to 900 degrees centigrade. And if we consider the sulfur dew point of, let's say, FO at around 180 or 200 for that matter, depending upon the operating condition, there is a clear margin of at least saving 230 degrees of temperature by preheating the air. Now, I would like to, having this opportunity to handhold or support MSME units to implement recommendations, we had also tried to help them with the design of waste heat recovery systems. And this is a short video of a particular furnace. You would find that the flame is actually coming out from the door of the furnaces from all areas. What I'm trying to focus in this particular video is that the flue gas which is supposed to come out from the chimney of the furnace is actually coming, maybe only 10% of the flue gas is coming from the chimney. But the rest of it is actually coming out from all pockets, the material inlet and the material outlet, which you could find on this side. So this poses a big challenge in designing the waste heat recovery system unless we install an ID fan. Now this is a typical waste heat recovery internal design that we had developed for a few units in Faridabad, and it has lower layers of radiation zone and the top layers for the convective zone. As you see, if we are targeting the temperature rise of the fresh air from 50 to 250 degrees as we increase, the surface area required increases, the weight of the recuperator increases, and even obviously the cost also increases parallelly. So trying to come to the barriers in implementing waste heat recovery systems in forging units. Some of the technical barriers are for continuous operation. The first two bullets are relating to the operating hours, annual operating hours of the furnace. The lower the operating hours, the higher is the payback, and therefore not very attractive. Issues with integration, it needs shutdown time unless there is an alternate furnace to run their business for continuous production while the recuperator is being installed. This poses a big challenge because for MSME units, as it has been explained by several speakers, production is the top priority. Lack of backup service network is again a very important point touched earlier. Hand-holding and seeding the local service provider so that there is continuous support. In terms of business barriers, apprehension of having negative impact on the production, they feel that the production batch time would increase because of reducing the fuel that is going in. Financing is an issue because of, in some cases where the fuel uncertainty price is an issue. Confidence is of course there, and the workmanship. Possible way forward we had thought were on, there are several MSME focused programs that are going on all over India. One could consolidate the successes as some of these success stories we had shown in the earlier slides. Large scale proliferation for the design and to make the vendors more aware of. And in most of the units we have interacted, the approving authority most of the times is the vendor who has fabricated the furnace. And therefore it is very much required to educate the furnace manufacturer who is fabricating in the premises of the factory to be educated towards the opportunity to save energy through waste heat recovery. Incentivize vendors for energy efficient products, maybe for example rating of products. And MSMEs are looking at the short-term gains. It's again a known fact that they generally don't look at the life cycle cost of the product and get a locally fabricated furnace. A few slides on our company. We are basically an energy consulting company, and we are part of a French MNC based in Delhi. 4 million ton of emission reduction, presence in 20 countries. And this is one interesting picture I took in one forging unit. A natural waste heat recovery happening. Thank you. Thank you.